Hello. In today's lesson, we're going to be looking at the bubble sort algorithm. So for a quick visualization, I grabbed this off Wikipedia. This is what bubble sort looks like through visualization off of Wikipedia. What is bubble sort? Well, it's when we take adjacent elements and we compare them and we swap them so that they're in order if they're not already in order. Let's look at how we can step through a small example. We'll go through it step by step. All right, let's write down a quick array that we can look at and step through sorting the algorithm using bubble sort. So let's say our array is 1, 3, 2, 7, 4. All right, so our goal is to compare adjacent elements and swap them if they are not in order. Okay, so we're going to compare these two first. So 1 and 3. Is 1 greater than 3? Nope. So we're going to drop down 1, 3. Is 3 greater than 2? Yep. So we're going to swap 3 and 2. So we're going to get 2 and 3. I put that 2 right there. Now we're going to have 3 and we're going to have 3 and 7. So is 3 greater than 7? Nope. So we're going to get 3. Well, I'm not going to put that there. I'm just going to drop down to 7. So we're going to get 7 and 4. Is 7 greater than 4? Yep. So we're going to swap them. So we're going to get 4 and 7. So we get 1, 3, 2, 4, 7. 1, 3, 2, 4, 7. Let's go through another pass here. So we got 1 and 3. Nothing there. So we got 1, 3. We're going to compare 3 and 2. Yep, 3 is greater than 2, so we're going to swap those guys. So we're going to get 2 and 3. Now we have 4. Is 3 greater than 4? Nope, so we're going to just leave that as 3 and 4. And now we're going to look at 7. So 4 and 7. Nope, we don't need to swap them, so we're going to get 4 and 7 down here. So we're going to get 1, 2, 3, 4, 7. And that's our sorted order. All right, so that's a quick idea of stepping through the algorithm. Now let's see how we can actually implement this in code. All right, in our Intro to C folder, if you have one like this, let's go ahead and make a new folder. We're going to make a new folder and we're going to call it bubble sort. Hit enter. Let's add a new file in here and we'll call it bubble.c. And I won't be extracting anything into a new function, but go ahead and make a bubble.h just to get in the habit. Okay, close this one and close this one. All right, so the only library that I'm going to bring in here is just input and output, stdio, the standard input output library. So include stdio.h. And we're going to define an enumerated type up here for the size of our array. So we're going to define max 10. Whoops, got the octothorpe symbol. All right, there we go. Save that. And let's make our main. And before we write any code, let's just make sure that everything's working. So we're going to printf hello. All right, I'm going to use control back. All right, I'm going to use control backtick. So if you don't know that command, you got to get used to this in Visual Studio Code. Control and this character. So on your keyboard, find this character, control backtick. We're going to use that to alternate between the terminal and the code editor. part of being a good programmer is knowing keyboard shortcuts. So Control backtick, you can see the cursor is now down here. I'm going to Control S to save, Control backtick, come back down here to the terminal, and I'm going to type G+. I'm going to change my directory into bubble sort, and I'm going to compile my code. So G++ bubble.c-output proc. Okay, type dot backslash and proc.exe and run it. Make sure that hello prints out. Here we go. So everything's working. Our code's set up. We're able to compile it. Let's go ahead and start building out bubble sort. Okay. So when I was talking about swapping elements, we're going to need some variable to store one element inside of another. Let's kind of look at this on a piece of paper real quick. Let me clear the whiteboard here. Okay, so we're going to need some variable called temp. Why? Because we're trying to take one part, so let's say this is AJ, and we have AJ plus 1 in our array, and like this would be AJ plus 2. But we want to swap these guys. So what we can do is we can say temp equals AJ and AJ equals AJ plus 1. At this point, we have this type of situation. Good thing that we saved that AJ in temp, because now we can do AJ plus 1. It's not going to affect this because we already did that signature, or we already did that assignment. It's going to affect the AJ plus 1 element. We can make that temp, and this guy becomes temp. So see how we can swap that? So that's our way of swapping elements in this process. So we discussed all of that in the whiteboard so we could kind of look at how we're going to set up the code. So we're going to have our int temp, because we're going to need that variable. We're also going to need an array, right? So we're going to have a, and then we're going to use our enumerator type max. Remember that max is really, it means 10. And then we'll use n for the number of elements that we want to insert in the array. Okay, so this is going to be the first program we're going to actually look at taking an input from the user. So first, you got to give some instruction to the user. So printf, please enter the number of elements that you would like to insert. Okay, and then let's have a new line break after that. Okay, now we want to get the number of elements that the user wants to enter, and we want to save them in this integer variable, integer type variable n. We can use a function called scanf. So this is going to take the input from the user. We've got to format what the input's going to be expected to be. So we're expecting an integer, that's why we're using %d. And then we're going to pass a reference. So we're passing in a reference to n. And what that's going to do is it's going to take the number that the user types in after they see this statement. When the user types in a number, it's going to store it in n. It will have the number of elements. Okay, so we know how many things the user wants to store, and we better hope that it's only 10, because if it's more than that, we got a problem. We're going to have an out of bounds exception for the array. So let's go ahead and get the, let's put in a no. up to 10 elements. Warn them, you know. Okay, so for int I equals 0, I less than the n that the user sets, I plus plus, we're going to say print f. We're going to go through, we're going to ask the user each time, what do they want to insert at each specific index of the array that we built. So printf, enter the data for element, I'm going to use a formatted string here, for element %d, and we're going to want to make this into, we want to use enter the data for element 1, 2, 3, 4, all the way up until n. So we're going to pass in I. And so every time that this loop goes around, what's going to happen is that I, if it's 1, it's going to say enter the element for, or enter the data for element 1. If it's 2, it's going to say enter the data for element 2. If it's 3, then it's going to say enter the data for element 3. So each time the value of I is going to show up here. And then we want to get those values and put them into our array. So we can use scanf again. And guess what? It's an integer, so it's going to be %d, format it. And then we're going to pass in a reference to the array at the index that we are telling them to set the data to. So what this is going to do is it's going to first get the number of elements the user wants to enter, and then we're going to store all of the data the user wants to enter in the array. So we can try this with various types of numbers in the array. Let's show them the array real quick. So for int I equals 0, I less than n, I could have just copied the code from above. What I'm going to do is I'm going to print out all the elements. But I mean, if you want to make these into functions later, by all means go ahead. This is just a way for us to kind of get through this example. So printf %d, and then I like to put a little line maybe to kind of show that it's in an array. And we're going to pass in the array at the index. So what this is going to do is we're going to get like 1, 2, 3. It's going to print out all the values that we stored in the array with a little line in between them. Okay, and then after that happens, let's print a line break. So we want to break that, we want to print out a line of all the elements that we just inserted, and then we're going to have a line break. And now we're going to actually do the sorting. So the first thing that we have to do is loop through the, we have to go through each element. Let's look at this in a visualization here. Okay, let me erase the whiteboard. So I don't remember the example that we had, but it was like 1, 3, 2, 4, 7. So what we have to do is we have to go once all the way through, and then we get our first 1, 2, 3, 4, 7. Now we don't need to worry about this guy, because it's been taken care of. And we need to go through again. We need to get 1, 2, 3, 4, 7. These guys have been taken care of. And then we're going to go through again in 1, 2, 3, 4, 7. we're going to keep on doing this over and over again. So we have to do it 1, 2, 3. We have to do it for the size of the array. So we got to do that first. We got to go over each one of these once, and then we have to go over the array for each iteration of this. So we're going to have some sort of loop structure that's going to be like for I and then for j, and we're going to look at that in the code. So in our outer loop, we're going to have for int I equals 0, I less than n, so the size of whatever the data is that the user is entering, I plus plus. This is our outer loop. Now we somehow need to loop over the subarray, so the unsorted portion of the array every single time. So we'll use j for int j equals 0. And this is our condition. It's going to be for j less than n. We know that. And then we are already going to need, we're going to be looking at adjacent elements. So what's going to happen if we just leave it like this? It's going to break because there's not going to be an aj plus 1 index to check. So we know right off the bat we got to subtract 1 because we need to have that plus 1 index. So we need to stop prematurely so we can do that last comparison. And then how are we going to do the subarray? Well, we're going to use the iteration from I. So for the index that's already sorted, we don't need to count that. So every time we're going to subtract I. So for the first time, it's going to be j minus 1 minus 0, this condition is going to be n minus 1 minus 0, n minus 1 minus 1, n minus 1 minus 2. So every time we're going to be using the ith index or the ith value from the outer loop to only keep us in the subarray. Okay, j plus plus. Now here's where we're going to do the swap. So we want to swap adjacent elements if one's larger than the other. So this is the condition that we're going to check. If aj plus 1 is greater than aj, so if the element that comes after aj is larger than aj, we're going to swap them. This is where we're going to use our temp variable. So temp's going to be our little storage container for aj plus 1. And then we're going to assign aj plus 1 to aj. And now we want to use our temp variable aj equals temp. Okay, so this should work because we're going over the array I times, and then we're going through our subarray and swapping adjacent elements until it's going to be in sorted order. Now we're going to show the array one more time, so let's just copy this code from up here. See, this is obviously a case where this should be a function because I'm using it twice. Alright, control backtick. I'm down here in the terminal. I'm going to rerun the compilation. It's compiled. And now let's run proc.exe and hopefully everything should work. So let's do 5 elements, and we're going to do 1, 3, 2, 4, 7. Okay, and the reason that we're getting the ascending order instead of the lower order is the way that we're swapping things. We just change this sign here. Now it's going to swap if aj is greater than aj plus 1. So this matches the thing that we looked at in the piece of paper. Let's go ahead and compile it again, and then let's run it. So what I say is 5 elements. Yep. We're going to have 1, 3, 2, 4, 7. Oops, I put in a 6, but the same thing. So now that's sorting it in the way that we want it to. All right, I hope that you found this video informative. So next part, I'm going to show you how you can upload this code to GitHub, and then that's going to be it. Here I am in GitHub, so I'm going to click in New, and I'll call this repository Bubble Sort. Bubble Sort in C. So the reason that I'm showing everyone how to put things up on GitHub is because it's an essential tool that we're using now. It's a thing that every developer should be comfortable with, and I want to see people using this more often in the beginning of their coding. I guess they're learning, because then people can actually see what you're working on and what you're doing on a regular basis. All right, so let's go ahead and copy this echo hash bubble sort, which is just the title for bubble sort. We're going to copy and paste this in the terminal in Visual Studio Code. Let's go ahead and click in the terminal here. All right, that's now created a README here. Now we're going to keep on copying things from that GitHub page. So the next thing that we have to add is git init to initialize a repository. Okay, and the next thing we want to do is git add README. I'm getting all this from the GitHub page that we have open in Chrome. Okay, now we're going to add our first commit. So I'm copying everything from that page in GitHub. And then git remote add origin. I'm going to copy that whole thing. Your URL is going to look different from mine. Okay. And now git push origin master. Okay, it's pushing stuff up to GitHub. Now let's type git status. Okay, we're missing these two files. Let's do git add dot, and that's going to add all of our files. So git status. Okay, git commit -m, adding bubble sort files. And now we'll do a git push. There we go, it's pushing it up to GitHub. Okay, here we are in GitHub. Let's refresh the page. Great, yep, here we are, bubble sort. So what I'm going to do is I'm going to copy and paste this URL in the video, and if you run into any issues, you can go ahead and just see what happened. All right, thank you for watching. If you like this video, please like it and subscribe, because I'll be putting out more C programming videos. Thank you.